to talk about what to do with rendering when you want to have provenance and you want to have unlimited compute. And these are things that the render network solves. The render network is something that is apart and separate from our work on our core software renderer. The render network is a distributed GPU blockchain system. The concept is pretty simple. There's a ton of GPUs out there. There's hundreds of millions of GPUs. There's only about 50,000 or so high-end GPUs on the public cloud. And the demand for rendering and even AI jobs now is just enormous. So what we've done is we've taken the price of a GPU minute or hour on Amazon, Google, or Azure, and we've translated that to, I guess, what you would say used to be Ethereum miners. And the effect has been a huge amount of compute power that's being offered to artists. And we've also brought in our partners from the public cloud providers, including Google, Microsoft, Amazon, and others. There really is no limit to the amount of nodes we can connect on the system. And some of these nodes from Azure and GCP and AWS provide really high-end security. Now, as you saw with the Star Trek piece, not all studios need that, but if you do, we have nodes that are reserved for that purpose. But we do have end-to-end encryption, even on decentralized nodes that are running on end users' machines. We've also broadened the scope of render to include third-party renderers besides ours. So one of those is Redshift. We've done a long-term deal with Maxon to bring Maxon's C4D engine plus the Redshift GPU renderer, which is a great bias renderer. And we want to show an example of Cinema 4D and Redshift running on the render network. So this is a great example showing something that is not our code, not our rendering engine running on the render network. There you go, final render in Redshift. Pretty good. And we've added similar features for Autodesk Arnold. You see here using multi-render, you can actually switch between Octane and Arnold on the fly, which is pretty cool. And the render network will finalize that for you. And we expect to add pretty much anything that is a render delegate, a hydro render delegate to the render network. But we're starting with these three renderers and going from there. The other types of jobs that we're adding to the render network are NeRF and light field renders. This is an example of how you'd set up a NeRF render or light field render in Octane. And this is the result. It effectively, on the render network, generates a NeRF and feeds that back into the rendering system. And you can still do ray tracing operations on there. NeRFs are pretty cool. As I was showing before, you can do light field renders. The NeRFs can also be used in AR, as you're seeing here on the left. It's a little bit splotchy, but it's pretty cool. And we have the capability to do really precise rendering with light fields. This is not a NeRF. This is an actual light field render running on an iPhone. And the light field is effectively providing all of the reflections and lighting information for at least 70% of the rendering. And that's why the phone is able to then render it at about 20 to 30 frames a second. And this is pretty great because it does allow you to do path tracing in near real time with an iPhone. Now, the other type of rendering job that, of course, we're adding is just straight up stable diffusion. You're seeing here on the left is the web interface for stable diffusion. And the ability for you to just type in prompts is pretty straightforward. But when you mix that with what you can do with rendering, there's some really interesting effects that you can accomplish. For example, you can mix Cryptomat with the ability to do in-painting. And we also have an entire Photoshop application through Photopia on the web that allows you to edit your renders. You can take your Cryptomat passes, you can blend these together, and you can run multiple generative AI jobs all on the render network from your render jobs. And I think the future likely portends having the ability to mix and match these things all within a single rendering pass. Right now, this is sort of an offline process, but we can also bring all of this locally and mix and match that with your IPR and real-time viewport. Now, I think beyond this, of course, is large language models like ChatGPT. Really, about a week ago, Microsoft released ChatGPT 4, and you're seeing here visual ChatGPT, which is on GitHub. It's Microsoft's framework for loading images into ChatGPT. And I think if you can imagine your renders or part of your render jobs, your render craft going into a large language model similar to ChatGPT and having your text drive and control that in ways that are very descriptive, it's, I think, even more powerful than what you're seeing today with Stable Diffusion and even ControlNet. So the future with AI, large language models mixed into the rendering process, I think is absolutely crazy. And we're going to see a lot of that explode, I think, over the next 4 to 5 months. I want to talk a little bit about the Render SDK. It's our portable graphics API and compute framework. We use it to build everything. So it's our way of loading in modules that are both AI related, rendering related, compute related, and it's actually, you know, useful for building entirely new renders or additions to the rendering jobs that you've seen already. But we're opening that up to almost anybody, and we're also putting this in the hands of the Render Foundation. The Render Foundation is a totally independent establishment. There's a DAO. It was created at the end of last year, and it assumes governance over the render network. So it's no longer OTOY that's controlling the render network. It is this DAO. And we also have regular votes on codifying how the render network works. And most recently, we established a vote on the token model. So there's a new model that we're moving to, which is called Burnt Mint Equilibrium. It's a BME model. It's similar to Helium, which is a token for Wi-Fi utility, and it'll be implemented later this year. Now, because Render itself is running on the blockchain, effectively everything that you're doing on it is already an NFT. You have a proof of render for everything. So even that one frame from that Star Trek movie is on chain. You have that receipt for it. Whether you choose to put it on OpenSea or sell it is up to you, but effectively all components of your render job are on chain. They have provenance, and we want to at least give people the ability to create totally new models around NFTs. And I think, you know, to look at where this might go, you should look at artists like Pac and Beeple that are, you know, some of the earliest adopters of both OctaneRender and NFTs. And the way that they're looking at things in the future is pretty interesting. So with Pac, for example, I mean, he does experiment a lot with generative NFTs. We have the ability to generate anything on Render, and it's effectively already, you know, encoded on chain. But what's more interesting is when you can take those experiences, you package them as a NERF or a streaming render job, which you can do on the system. And you can see here it's running back as a web page. This is the kind of thing that I think makes an NFT a lot more interesting, where you can take an experience, you can package that up, you can have others recompose it and add to it. And it can leverage everything from Unreal to Octane to Brigade to NERF to light fields. All of it is possible. You can even package an app. For example, we can have Octane encoded in an NFT, and you can sell access to it. So this is, of course, very metaverse-like. And I think the metaverse, in my mind, is spatial 3D on the web. You do need open standards, just like the web. And I think that's so fundamentally important. Without that, I don't think you're going to end up with a metaverse that any of us really want. And to that end, we've joined the Metaverse Standards Forum. We're also part of IDEA, which is the open source group that's taking our Orbex data format that's coming out of Octane and Render and turning that into an open spec. And the Metaverse Standards Forum, I think, is a really promising endeavor towards that goal. It complements all the work we're doing in IDEA. And we want to put these open standards to practice with projects like what we're doing with Alex Ross, who's a good friend and an amazing comic book artist whose great work you're seeing here. Alex and I have been thinking about the metaverse for, my goodness, about 10 years. We collectively with John Carmack did Render the Metaverse with Oculus, and we're taking all of his work, his life's amount of his life's work of art, I guess, over the last 30 years, and effectively building 3D models, encoding that on the chain, on Render, and having that at least there for posterity. And the work that we're doing, of course, from Alex's corpus of art is enormous. I mean, it covers everything from Marvel, DC, sci-fi, most of pop culture in the last century. And as we're looking at the ontology for how to categorize all of this amazing work and many other artists that can link to it, we decided we needed an index, and that's where the M token was created. It's effectively an abstract concept token, and it allows you to link data through concepts that are defined on Wikidata. And with this, you can actually have some sort of concept primitive that allows you to define how stories are interconnected, characters are interconnected. You can link everything from fandom.com to wiki pages to Notion documents. And these are things that are effectively really important for having ground truth for content and IP. And we're going to put this to use for the Alex Ross archive, and also for other archives as well. And that includes Beeple's archive. So I'd mentioned this project going back to 2021, and I also brought up Beeple's interest in going beyond NFTs. And I think that, he's done some remarkable work exploring conceptually, how digital art can be represented in a form that is respectful of the artist, that is deep, that is profound, and that still has a lot of value when you're buying effectively a unit of it on chain. And a lot of what he's been exploring have been concepts related to generative art, time-based art, physical art. This is an example. It's one of my favorite Beeple pieces of art. It's from 2018. It's one of his everydays, and he let us borrow it to show how we could use it in all these different forms. You can load up the piece of art as an Orbex file in the iPad app. You can load it in a browser stream, which we're doing through XIO here. And more interestingly, we can package it up in a configurator. So this is where some of the concepts that people has had around being able to create art in a time-based fashion by remixing his own work or his own concepts has come into play. These are screenshots from a test that we did last year with Mike. And the way that it works is that you have a certain amount of time. See here, you have a stock scene from one of his everydays. You can then bring in objects from his other artwork and other pieces of content. And within a certain amount of time, you get to make your own everyday as well. And it's a lot of fun, and it's beautiful. It's easy. You effectively get really beautiful renders out of it. They get rendered on the Render network. And it's just an early experiment, but it is something that we want to work with people on integrating in the coming months. And here it is running in real time, which is pretty cool. So one of the things that probably connects what you just saw to Mike's future work is his own experiments with time-based art. So I was actually just at the opening of Beeple Studios not too long ago. See here, it was an amazing event. He's got a lot of physical art on display. And one of the things that he did at the opening was he made about, you can see here, about 20 or so pieces in a couple of hours. And the idea was that he was showing that the way he sees art, it can be created in a time-compressed fashion, and the tools that are evolving allow us to do that. As you saw in the earlier example, those tools are now available on the web, and we can hook up Octane to that and really make it even simpler than any DCC. So there is a lot of merit to this kind of thinking, and it's something that we think is a huge part of where NFTs and digital art and even consumers' intersection with that might be heading. And the other thing that's a big part of Beeple's focus is connecting his digital work to the physical world. You see here, I'm at the at a studio with this mountain of everydays. There's about, I think, 8,000 on that wall. It's an enormous amount. There's also a lot of physical art that's there. And one of the really interesting pieces is this one, which is a it's basically 4 LED panels that's meant to simulate a holographic box. But we are bringing the Light Field Lab display panels to fruition here, and we want to develop this this very same workflow that people's been developing on just normal LED panels with holographic display panels. So those things have about a gigapixel of rays to shoot out. So it requires a huge amount of GPU power, but over the next few years, we think it'll become tractable, and it'll be physical art like this that can push the envelope and make something like that really beautiful. The last render archive that I want to cover is one that is near and dear to my heart. It is the Gene Roddenberry Render Archive. We announced this on Gene's 100th birthday, his centennial, a couple of years ago. And like the other render archives, it's meant to cover his entire corpus of work. In the case of Star Trek, though, you're dealing with 60 years worth of stories and history, and I mean, it's 800 hours of television, 13 movies, just an enormous amount of work. And so we started modestly enough, just scanning in documents going back 15, 20 years. This has been a project that's been in development for multiple decades. But a few years ago, Rod Roddenberry, Gene Roddenberry's son and my partner and a very close friend, decided to take things a step further and start to build the things that are in Gene Roddenberry's lifetime of work as visual artifacts, including the USS Enterprise, a life-size version and a production version that would represent what was filmed. And so this sort of modality has really been promising. It got a lot of attention, and the goal of this project is to effectively build a life-size digital twin of the USS Enterprise, as you'd seen it in the motion picture and the TV shows. And we've actually gone about 30% of the way there. We're about a year and a half into it. We probably have another few years to go before it's completely done. But the work already is just breathtaking. It's beautiful. And it's not just the Enterprise. We're actually building the environment around it. So we have a one-to-one life-size Earth. You have a one-to-one life-size universe, solar system. At least within everything that's documented in Star Trek, it's there. If it shows up or it's mentioned in a Star Trek episode, we build an equivalent of it, and we try to make it as real as we can. And within that context, the micro and the macro are both represented at this incredible fidelity. You can see here we're also carefully matching the things that were in the movies and the TV shows and making sure that they are visually identical. They're also explorable and interactive, so you can go through the engineering section to push the buttons, explore the bridge. It's all meant to be like a museum, a living museum that you can walk through and explore. And this is the bridge from the motion picture, Star Trek motion picture from 1979. Gorgeous piece. Going forward chronologically, here's Star Trek II. You can see here the first couple of movies almost nearly perfectly matched. And of course, we have to go further than just the sets and think about characters, and I'll discuss that in a little bit. But we have 30 years of engineers and designers and artists that have been working on Star Trek that are giving us all these blueprints, all these plans to figure out how this all goes together and how this fits in within the timeline of Star Trek. So it's not just one Enterprise that we're working on. We have to think about the fact that the ship itself changed over the decades and the years as the show went on, and the movies followed that. And even after the Enterprise was retired, there was future Enterprises. There's actually 14 in total and counting from the different eras. And one of those future Enterprises is the very popular one from the 90s, Captain Picard's USS Enterprise, which you can see here. He ended up having, in fact, two. This is from the Star Trek The Next Generation movies. And we build these things in a combination of Blender, Unreal, Cinema 4D, all of which connect to Octane. And the attention to detail, again, this is one of the more recent examples. You go to Picard's ready room, you'll see that there's sculptures of his ships. His fish from the from the 90s episode is perfectly well represented. It really is a world that's brought to life in exquisite detail, and I think that's truly where the metaverse, is heading. Something that is beautiful like that, I think, is meritorious of the moniker of what we want to see in the metaverse. This is some of the work that is coming ahead for the Roddenberry Archive in the year ahead, and we've got everything from other shows like Deep Space Nine and Voyager to the J.J. Abrams movies to the more recent Strange New Worlds, or Star Trek 3 and 4, which complement the other movies, bridges that you'd seen, and Star Trek Enterprise, a show from 2005 that I mentioned earlier. And even some of the work on the early sketches for unproduced Star Trek movies is something that we're taking a very close look at. There's a big part of this project that involves taking things from the real world. And photogrammetry, of course, is something that's well known to a lot of artists. We've got Lightstage, which does this absolutely breathtaking scan of digital objects and assets. You see here, this is the phase 2 physical model, the blueprints above, and the renders on the bottom right. And thanks to collections from the Paul Allen Estate and others, there's just this incredible wealth of physical artifacts from Star Trek that we can scan in and create digital doubles of. But we don't need to do that. We actually have such incredible artists on staff that they can pretty much create these assets from whole cloth, like you're seeing here. But we do, when we can, have both the scans and the physical assets and the digital versions replicated where we can. And in cases where they overlap, well, then we have both. And you can see what the physical asset is and the digital recreation is. And there's a need for both of these. I mean, one of them is something that's meant for posterity. The other is meant to be used in a in-universe interactive experience or even virtual production. And in those cases, a scan is not necessarily going to be the best version of what you want to have. You want to build it from scratch or have the scan inform the digital version. You see here some of the interactive pieces that are enabled in the digital one-to-one USS Enterprise. Bathrooms, work toilets, flush, pretty crazy. I do want to mention that we've been working with NVIDIA on this project as well. We showed some of this work last year. We've been making sure that what we're doing on the Roddenberry archive also connects to NVIDIA Omniverse. And yes, we have connections to Unreal, but with Omniverse, there's also a wealth of GTC tools and workflows that are really valuable. And so being able to take everything that's in the Roddenberry archive and have an Omniverse connector through Octane that can bridge these things is critically important. And I think that also leverages a ton of amazing work done by the NVIDIA Omniverse team going forward. And we're excited to take that further in 2023 and 2024. We've been working with Roddenberry, CBS, and others also to create industry standards around USD. Of course, Omniverse leverages USD, and I think that's one of the fundamental pieces to all future metaverse standards. USD is a pretty great piece of that system. And with Material X and OSL shaders and other things attached to it, I think there's a lot of momentum behind that as an open standard for the metaverse and possibly for digital art and collectibles going forward. So the story of Star Trek is something that is just as important as the assets and the renders and the images. And so as we were looking at archiving that, we started at the very beginning last year with The Cage, which is the pilot episode of Star Trek that was filmed in, you see here, November 30th, 1964. And when we put out the first bit of the Roddenberry archive that was related to The Cage, it got a lot of great attention. As you can see here, we brought in performers, actors, and we even brought in the director, Robert Butler, who directed that pilot episode 57 years earlier. It was an incredible experience. I want to play a video showing the interview we did with him. I was very nervous bringing Bob Butler in, showing him what we've been doing, having his thumbs up. It gave me goosebumps.
I was aware of the size that this show has become. I saw the size there. I saw the size here. Testimony to the quality.
It's been really rewarding to see the feedback from those that actually worked on the show coming in and seeing the world of Star Trek as they remember it brought back to life. That's where the magic of the work that we've done really kicks in. We're at the point where we're looking to rebuild or reconstitute these uniforms digitally, physically, scanning them, putting it performer. There you go. That's a remarkable testament to get from the director of that pilot episode. And you can see here, we have a digital pipeline, physical pipeline, a scanning pipeline, but it all sort of comes together and the results are just beautiful. You're seeing here 1964, 2022, it's almost indistinguishable from the original. And the results just look beautiful. I mean, in fact, as we're taking things from the 60s, we want to render them as they were in the 60s. And as we go to the 70s, same thing, right? So there's a lot of work that goes into just figuring out how the cameras and the lighting and the films and the emulsion of plates work to get everything to look just right as it did back in the back when the shows or the movies were filmed. And going back to the virtual production side of things, the piece that I showed earlier had a predecessor. Let me play it for you. So that was the very first test that we did before we put out the longer 1 minute piece that I showed earlier, and that actually had 1.5 million views on YouTube. It was something that organically got a lot of attention. A lot of the pieces that you're seeing come from Star Trek literature, not necessarily the movies or the TV show. About 40% of the story of Star Trek, believe it or not, comes from the novels, the comic books. You can see here we're matching those pretty closely. And a lot of the stories that are in those books inform and create the things that end up being filmed later on. So they are really important. And some of those important stories are actually written by Gene Roddenberry, and they were unproduced or extra drafts of things that really show a lot of the intent of the creator. And that's something that is more important to us in some respects than some of the minutiae of the episodes. So for us, capturing the things from the novels, the books, the unproduced drafts of Mr. Roddenberry, these are all things that are driving, I guess, the 5-dimensional world line of the structure of Enterprise and the story of Star Trek. I want to focus on the characters. Now, in the case of Yeoman Colt, before we had a performer that looked just like Laura Goodwin, the original actress. In the case of Spock, we started with the CG Spock. I showed this 3 years ago, and you can see here the CG Spock was being used for a shot with him in a helmet. But when it came time to having that performance be brought into motion, it just didn't make sense to have it being done any other way than with an actor and a performer. So I mentioned before we'd had a performer, Lauren Selleck, using a combination of heavy prosthetics and a digital makeup, which you can see here. Those are added for the eyes. The combination's pretty great, but it's still a lot of work between the physical and the digital. You can see here, poor gentleman was ensconced with a lot of prosthetic makeup. We have our digital Spock model here on the right, and the combination is pretty great. We basically 3D printed all of the digital pieces, put them on his head, and it looked great. The problem is it was difficult for him to move and do a performance with the prosthetics on. So the digital pipeline that we came up with, which works, by the way, completely in real time, as you're seeing here, allows us to mix and match the digital and physical prosthetics as needed, and the performer can do their job really without any markers. And this is all being rendered and lit live on a 3090, actually. We have another tool in our arsenal here, which is we can scan in the actors with super high fidelity, as you're seeing here. And then we can do effectively camera motion after the fact. This is incredibly useful for relighting. This also means that we are able to effectively direct the shots after the performers have done their piece. And it's not usable in every single instance, but it is something that when you can put two performers in the middle of this capture volume, the results are pretty spectacular. And we did A/B testing, in fact, ABC testing, where we effectively tried this method with more traditional alternatives, where, for example, in this case, we had green screen or NURBS, in fact, which we tested alongside the digital scan. But the digital scan version of the performance actually ended up being the one that was used in our final render. The quality was phenomenal, and we did an A-pose of the performer and then had a machine learning algorithm track their movements and then move their body in motion. And that's what you end up seeing for about 3 or 4 of those shots in that piece. And we put that to work as well for Lawrence's performance of Spock. As we move forward in the virtual production pipeline into this year for the Roddenberry archive, we're actually doubling down on creating a lot of physical assets and props. Our virtual set before was purely digital, including the chair. Now we're building these physical chairs. We've also acquired a lot more assets to scan in. Even digital characters that we had created for a previous short. This is Arex, who was from the animated series, all digital. incredibly popular. People loved that we created that digitally. So we went ahead and we built this physical 3D printed model, which we've scanned in and can mix and match that with physical performances, which is pretty exciting. We've also started to figure out how to capture large environments. This is done with Luma Labs and a drone. Luma Labs makes great software for NeRFs, and those NeRFs are available effectively through an API to be brought right into Octane's neural rendering system. And you can see here the NeRFs are awesome. I mean, they do capture everything from clouds to far field objects. I mean, they're spectacular for doing really complex captures. And in the next slide, I'll show how it looks inside of Octane. Effectively, a NeRF render can be treated like an SDF with various reflections properties, but the quality is pretty good. And we've also mixed and matched various different things. We don't just use NeRFs, we also have laser scanners, and there is some work that's done by the digital artists as well to provide a final render. So it's a mix of many different systems and tools, but NeRFs are relatively new. They weren't really a usable asset framework a year ago, but they are today, and that's pretty great. For the character performances, what we did last year with Spock was really focusing on a single version of Spock. There was one age that we focused on, which was one here in the middle, which was the motion picture. But Leonard Nimoy played Spock over 50 years, and we've similarly had to have Lawrence figure out how to portray Spock over those same 50 years, and it's been challenging. We've been able to build a full 3D version of each of the heads that he is driving through his performances, so we can age them, relight them, and even bring them, as you can see here, into the iPad app. So you can see here on stage while we're filming, we have effectively the ability, we play that again, we have the ability to relight and move the camera around as we're doing the shoot, and it's pretty powerful. So you can see here's the set, here's Lawrence. We're doing a real-time live performance of his face, and it's connected to the Octane asset that's being shown here on the iPad. We can change the lighting, and it can adjust the lighting in the virtual production stage as well. And this can happen while the actors are doing their performance, while we have people on set. It's very early part of the pipeline, but we're putting it to good use for the current project that we're doing. And we're also going insanely detailed on geometry. This is for the this is all rendered in Octane, and this is for the new piece that we're working on. It's by Aaron Westwood and JJ from BLR VFX. It's gorgeous, and can't wait for people to see this piece. It's going to be amazing. We also have many other artists that are working on building beautiful, crazy worlds that are pushing the envelope for meshlets and other things that we want to leverage going forward in the future. And the future of rendering is very much in the hands of creators, and the tools for rendering are becoming easier and more powerful and better. And I think that virtual production and virtual worlds go hand in hand, and you're going to see a lot of beautiful work being done by everyone that's in the digital art space, and possibly a whole new swath of consumers that get exposed to these tools with utility through AI and other systems that make this much easier than it's ever been before, and hopefully democratizes the content creation pipeline for artists. And we have to remember that at the end of the day, really, artists are humans. And I think that as great as AI and all the tools around them can be, it really is important that humans are at the center of content creation and the experience between all of us as we appreciate and love the art that gets created. Thank you, everyone. This is GTC 2023, and I'm Jules Urbach signing off. Take care, everyone. See you next year for GTC 2024.